snow, blizzards, and driving winds. Cold so severe that mere breathing is an effort. In climate like this, just a few hours of exposure can stop an army in its tracks. But newly developed fuels, lubricants, and special equipment now make possible the efficient operation of automotive materiel in even sub-zero temperatures. Let's get in out of the cold for a look at some of the equipment being issued to operating units in the form of winterization kits. In principle, all the kits are designed to ensure quick starting and continuous operation. However, since each type of vehicle has its own winterization problem, kits are packed to fill the needs of a particular type of vehicle. For example, the Jeep kit contains a tailored snap-on hood covering which keeps the engine warm. The kit for half-tracks furnishes plastic covers which fit over the portholes in the doors. These covers keep cold out of the cab without affecting visibility. Tanks are provided with a specially constructed windshield and hood which protects the driver's head from the cold. This unit is also equipped with an electric windshield wiper and defroster. The main components of the kits are gasoline-burning heaters of two types. Standby heaters to maintain engine temperatures during extended parking periods, and quick heat units used to warm up critical parts of the vehicle just prior to starting. One of the standby heaters is this hot air type, which is used in some tanks and tank-like vehicles. It heats the entire engine compartment and operates continuously during long parking periods. In the control box are contained the operating switch, fuel switch, and circuit indicator. A fuel adjusting valve regulates the amount of fuel passing into the burner element. Through this terminal box, the heater is connected to its controls located in the driver's compartment. A circulating fan draws in air and forces it through the heater where it is warm. Warm air is then blown into the engine compartment through the ducts. An exhaust tube leads outside and draws off fumes from the heater. Here is a typical installation of the hot air standby heater in the M24 light tank. In this vehicle, the heater control box is mounted in the engine compartment where it can be easily reached. The heater itself is placed on the floor of the engine compartment between the two engines. Another type of heater installed in tanks and tank-like vehicles is the high output heater, which is of the quick heat type. It is used for approximately 15 minutes to heat vital engine parts just before starting. A motor generator drives the unit. This is the fuel pump and the ignition transformer. As the blower turns, it sucks in air and forces it through the air inlet connection. A shielded cable leads from the transformer to a spark plug in the ignition chamber. The air passes through the chamber and into the burner tube. In the ignition chamber, air is combined with fuel from the pump and ignited, forming an extremely hot blast in the burner tube. Through this heat distribution tube, the hot air is forced out to critical parts of the engine. In this manner, they are warmed up before the engine is started. Here is a typical installation of the quick heat unit as used on the M7 gun carriage. The heater is mounted in the right rear corner of the engine compartment. Heat is directed to vital engine parts through these tubes. During parking periods, cold air, snow, and ice are kept out of the engine compartment by means of an adjustable air inlet shutter, which is also furnished in the kit for this vehicle. A slave battery outlet receptacle is provided to facilitate the use of battery boosting equipment. Batteries are warmed by hot air from the heater. It enters the insulated battery box through this tube and circulates around the batteries. Mounted in the driver's compartment is the heater switch box. It can be adjusted to automatically shut off the heater when a specified time has elapsed. One of the simplest standby units is the under-chassis heater. When issued with an 18-foot square tarpaulin, it may be used as a field expedient on any vehicle not completely winterized. Inside the guard is the float valve. This device regulates the flow of fuel to the burner unit. The heater is ignited by inserting a lighting wick in the door. A flexible fuel line carries gasoline to the heater from the vehicle fuel supply. Vehicles which use the under-chassis heater as part of the standard winterization kit are furnished with a shroud, tailored specifically for their needs. This tractor is being bedded down for the night. The under-chassis heater is stowed in a box mounted on the fender. It is connected to the fuel supply of the vehicle by means of the flexible fuel line. In this case, the tractor is equipped with an overall top. To light the heater, a lighting wick is used to ignite the burner element. After being lit, keep the heater off the ground. It should be hung underneath the vehicle by the hook provided in the kit. After the shroud is in place, weights are used to secure it against wind and weather. With the heater lit and radiating heat and the shroud in place, this vehicle will start quickly in the morning. Another type of standby heater, but one that is used on liquid-cooled engines only, is this coolant heater, which warms the liquid and distributes it through the engine block. A battery pad keeps the battery from freezing by circulating warm fluid through these channels. This is the fuel shutoff valve. A fuel metering mechanism automatically regulates the flow of fuel to the burner. This is the wick housing. Fuel is ignited in the burner unit. Coolant enters at this connection, passes through the heating unit, and leaves the burner at this outlet connection. Exhaust fumes pass through the heating unit and out to the air through the combustion chamber top and telescopic flue. The operating lever is connected to a rod which extends into the cab. When opened, fuel and air are allowed to flow into the burner unit. Here is a 6x6 which has just been completely winterized. It is now equipped with a manifold priming system which helps to get the engine started. Operating the hand primer pump carries fuel through the fuel lines and injects it into the intake manifold through these nozzles. This enriches the mixture in the combustion chambers, making engine starting much easier. This is the positive crankcase ventilating system, which draws crankcase vapors from the rocker arm cover into the intake manifold. The oil filler pipe includes a small oil bath air cleaner. Fresh air enters the crankcase through the air cleaner and oil filler tube. The kit for the 6x6 also contains the coolant heater previously described. The heater's fuel tank holds 5 quarts of gasoline, enough for normal overnight parking. To fill the tank, remove the gasoline filler cap. The telescopic flue stack is unlocked and extended before lighting the heater. The slave battery outlet receptacle is used to help start vehicles when their batteries are weak or dead, but more about that later. Hose connections circulate warm liquid to the battery warming pad, which is located here. Other hoses lead back into the cab. The liquid flows through the cab heater, filling the cab with warm air when the switch is flipped on. Fogged and ice-covered windshields are dangerous. Packed in the kits are defrosters and frost shields to keep the windshield free of ice and snow. Radiator covers included in the kit help keep the engine compartment warm when the vehicle is parked. An adjustable feature permits control of engine temperatures by varying the amount of air entering the engine compartment during vehicle operation. Hood louver covers are also furnished in the kits. They too prevent cold air from blowing in over the engine and help in maintaining engine temperature while the vehicle is operating. Completely winterized vehicles, properly operated and attended, can be depended upon to give satisfactory performance in sub-zero temperatures. Here's an opportunity to see how the coolant heater is placed in operation. First, the driver gets under the hood to check the fuel tank and open the fuel line shutoff valve. After closing the hood, the heater flue stack is raised by pushing down slightly and turning it to the left. Inside the cab, the heater operating lever is pulled out. Wait 2 or 3 minutes to permit fuel to reach the burner. Then the heater ignition switch must be pressed down and held for 30 seconds. Light smoke rising from the flue stack shows when the heater is lit. Some kits which have been issued do not have the electrical lighting feature. In such cases, heaters may be lit manually by applying a lighting wick directly to the burner element. With radiator covers adjusted and heaters burning, these vehicles are well protected against the cold. During the night, when heaters are in operation, a guard must be posted to keep on the alert for possible fires and to check the vehicles from time to time to see that the units keep burning. Where a battery failure occurs or where a vehicle will not start due to cold, this auxiliary winterization equipment has proved very valuable. Called the slave kit, it is generally mounted on a small truck so that it may be made available quickly wherever it is needed. Flexible metal tubing connected to a high output heater warms up the cylinder block, manifold system, and other parts affected by the cold. Equipped with 8 6-volt batteries of the 2H type and a 24-volt generator, the slave kit can deliver 6, 12, or 24 volts depending on the electrical system of the vehicle to be started. A cable is connected to the slave battery receptacle of the stalled vehicle. But first, all electrical equipment on the vehicle must be turned off. After the switches on the panel are set for the proper voltage, the outlet line is plugged in. Getting the Jeep to roll now is only a matter of starting up the motor. Heaters must always be shut off before vehicles are put in operation. To do this, first the operating lever is pushed down, shutting off the supply of fuel and air. Then the flue stack is folded down. A half twist to the right unlocks it. Next, the fuel shutoff valve must be closed. Failure to do this may cause a fire. To start the engine, use the primer pump several times. Open the choke all the way and the throttle 1/4 to 1/3. In the meantime, depress the clutch pedal and step on the starter. Keep priming the engine slowly until it catches. Designed to keep vehicles operating at peak efficiency in extreme cold, the equipment furnished in these kits must be carefully installed and maintained for best results. Packed with each kit are installation and service manuals, which should be retained and used as a service reference. Experience in cold weather operations has demonstrated that makeshifts and halfway measures are dangerous. Follow only authorized procedures as outlined in official publications.